So, hello everyone, welcome to today's educational video on solid principles in Java programming. Solid. Solid are some design principles we need to make sure when we are designing any software application from the scratch or creating any new software components or any new feature enhancement. There are certain sets of solid principles, certain sets of design principles which we need to take care as a developer when we are developing a new component or any application. So SOLID is an acronym that represents a five set of design principles for writing maintainable and scalable software. This principle help us create flexible and efficient code. So let's dive in. This is the introduction. Hello everyone. We'll start with the first one. First up is that we have is S letter in the SOLID, which stands for a single responsibility principle or SRP. Now, this principle states that a class should have only one reason to change. In other words, a class should have a single responsibility or task. So, I will demonstrate and explain you what is a single responsibility class in this video on a hands-on project that we'll create in an IntelliJ IDE. I've already created the Java project in the IntelliJ IDE and I've already added a package called com.company and single responsibility. And this project is a simple Java console application which will be running a main class. So this principle can be attached in any software application. For suppose if you are having any REST API which is using the APIs to expose its resource as an internal application or to any other request. So it uses the HTTP protocol request response and it uses the servers for communication. So at that time, this kind of principles are also be responsible. So moving ahead with this hands-on, I will display out some of the code which I've already gathered. So this is the code which we will discuss, and this code right now is in violation with the single responsibility principle. That means the code or a class should be only handling a certain single responsibility or a single type. It should be focused on doing only one task instead of doing multiple tasks or multiple responsibility. So here if you see in this class, we'll focus on one user controller class. The controller class is basically having a reference to a store object, and the store object is a simple Java class which utilizes the hash map data structure to store a user's object. And a user you can see is having three properties: name, email, and address, have string type. So the store basically is using the hash maps data structure to store this user's information into our memory, and the user controller is controlling the actions and the creation and other tasks. So as you know, controller classes are those classes which used for handling or communicating with the, the third layer of the application. Instead of doing the saving part or the code or the coding part, it is the controller responsibility should be only a single responsibility. Here in this code, if you can see, it is using multiple responsibilities. Like for suppose it already is, yes, it is valid to have a create user because that's what the task of a user controller should be ideally, but it also does an additional task or also does an additional takes up an additional responsibility of validating the user, which comes under the business logic part. So validating an object is not something which should be a good thing. So we will fix this thing. We will follow our design principle. We will not violate this principle and uh, apply this use is valid method into another object which will allow to segregate the code. So the reason behind this principle is that in future, let's suppose the business logic changes, the validation steps changes. So it will be not wise to make code in changes in the user controller because it's not its task or its responsibility. Back and forth from production to test region, thus it becomes a responsibility of developer to make the follow the principles that we have defined. So first principle is that single responsibility principle. So we'll follow this. We will make this code change, go into another class, and that class will do the validation thing. Only task for the user class will be to create the validator object. So I've already created a user validator and create a public boolean, a boolean type. validate user. It should accept the user object, and let's paste the code that we obtained from the user controller. So this will return and invoke this is a valid user, passing the user object and validate the user. So here we have taken away the responsibility of unnecessary responsibility of the user controller class. It just creates the user based on the string user JSON that will pass from the main class. So here user controller should definitely create a user validator object. This is usually coupled, so uh, this validator can be changed a number of times without effect without keeping the user controller as unaffected. That's the goal. That's which we are trying to do. Here we create a validator object and then we will create a boolean valid flag. Valid flag will store a boolean type and it will call the validation business logic that we earlier was using it within the class. So it's spelling mistake, valid error, passing the user object, and then it will check if this is a valid user or not. So here in case of error it should not be valid, so it is exclamation mark valid. Valid is having small letter valid. This we are done. So with this the code looks good. Now let's just look at the main object. It's is testing two scenarios. It's a good idea to always go with the test driven development approach where we will create. So here I could have used JUnit and Mockito, but right now I'll keep it simple. We'll use valid user JSON and invalid user JSON string class string object, and that we will be passing into the user controller object to create this user with the particular properties in a JSON format, and here it will pass the success validation logic, the validation business rule from the is present and is valid email, then this should be correct. So let me just run this. I'm testing both valid and invalid scenarios. So it's running in the sense. So moving ahead, first thing is that we have discussed the first principle, that is a single responsibility principle. Further ahead, we have the controls that I wrote it the last time. So these are the five principles. First one is the solid responsibility principle that we just discussed now. Simple one. Second is an open for extension and close for modification that we'll discuss in the upcoming video. L is for list scope principle, and there is followed by an interface aggregation, which is another interesting principle that we should be aware when designing softwares. And then there is dependency inversion principle, and its spelling is wrong. Dependency inversion is an important principle. Dependency inversion principle that we should discuss now. Don't save it right now. Let's see the result that we got in the IDE, and it executes fine. So the validation logic works fine. Let me just do an invalid XYZ over here. Let's just give 123.com, which is not a valid email format. So in that case, the success should be failing. We're not debugging it right now. Run it. So this should be failure. Anyways, the goal of the hands-on was to understand what is a single responsibility in terms of Java object class, and then what it should do and how we should do a code refactor if a developer has not followed a single responsibility. So this is the end of the video. We will be discussing the second principle, which is open for extension and close for modification, in the next class. So thank you for your time and thanks for watching, and we will meet together again into the next video. Thank you.